All right. Welcome back from the break. We will wait a few minutes as usual. While I check that things are working. Yeah, so usual, help from you guys if anything is not working. Oh, thanks, Yongli. You know what I'm gonna ask? Yeah, can hear me, right? So if I'm sharing the wrong screen or anything, just let me know, right? Okay, I am going to check if the YouTube stream is working. Okay, looks like everything is streaming fine. And the fan on my Mac just turned on, which it rarely does. So hopefully it doesn't spell trouble. Let me just see if I can close more stuff. Okay, let us just start back here on Slack since it has been pretty quiet. Okay, if you haven't joined week 8, please do. And this week we are having this objectives. Hopefully you have inculcated this habit to look at what you're supposed to do. Okay. So differentiate common interaction mechanics in immersive applications, using a few terminologies here, which it's not the most common, but the VR, AR, it's not the most mature field of study or field of practice even. Okay, so some terms you may not be able to easily, find and refer to online that mean the same thing. Okay, but I'm trying to use some things that I find can portray what I'm gonna say in the best manner. Obviously, also based on whatever that I've read in the whether research or online articles, try to match them. Okay. So that's differentiating interaction mechanics, explaining how different hardware components implement this so-called mechanics. And then I also introduced two terms called, not I, but people have introduced these things as dimensions to help in thinking about how to design for each one of your XR applications. Okay, so I think it's useful to know. Okay, whether you use it or not is another issue. But as they always say, you need to learn what is out there, all right, first before inventing any ideas yourself. And it also makes it easier, right, if you want to do something different. Okay, lastly, this application of the mechanics and authenticity. So natural and artificial interaction, I have coined this word called authenticity. Okay, interaction authenticity. And, just see how you can apply it in designing your stuff. Okay, the video is there. Hopefully you have already already seen it. Okay. Otherwise, you would need to do it okay, at some point. If you have seen it, obviously you have advantage in the quiz today. Okay, because I mean the casual quiz, non-formal quiz, which we are going to do now. Okay, as usual, as a way for us to revise and highlight essential things. Okay. Not saying that the rest of stuff are not essential, but just emphasizing things that are more important to be remembered. Okay, live stream happening now. Other things that you should be doing are obviously the stuff that you should. That the stuff that you need to do to fulfill your assessment requirements, which right now the focus should be on the B set of requirements. Okay, the lab this week will be virtual. Okay. So, speaking of the submission, we have finished marking, except for those which we still are unable to access your repositories for one reason or another. I just need to write the script to go and commit to all your repositories. Okay, otherwise, adding one by one to the individual repos would just take too much time. So let me get to that this week, definitely. Okay, so I will commit the feedback.markdown file.md file to each one of your individual repositories so that you can see what is wrong as well as what you did well, okay, for your A submissions. Okay, this is just a quick consolidation of some things I remember that I noticed, okay, before we start the interaction lesson now, since we are talking about this. Let me just, I'm always wary that, my share screen has issues because recently, every time OBS updates, I think something is going on. I mean, something may go wrong. So, yeah, for the video recording, the submission you guys made to record a chemistry-ish lesson, okay, using the VR markers, sorry, not VR markers, AR markers that Songjia has provided. Okay. Yep, I understand that this is like it's not very much of anything to do with your capability, your ability to implement an immersive application, but still, it is a big part of the task, or rather, it is also a learning opportunity that a lot of us who are dealing with AR would need to understand how to do things properly. Why I'm saying this is because, yes, I see that a lot of you did not angle the camera like straight down. I understand there are practical issues with that. I'm not sure examples, but I think describing it in words, probably you can know what I'm saying. Actually, let me just pull up a set of AR markers. I'll just use the one that Songjia has provided on the Docker. Okay, let me just change the screen. Which one is better? Can you see? Okay, this is better. Okay, so AR markers. A lot of you like angle the camera like this, like how I'm doing it like that. Obviously, this is gonna give you not so good results. The tracking would go off pretty often if it can track at all. Okay, so you certainly need to do it, straight as possible down if you're using AR markers, which is super common. And I think it's something that is quite obvious, but maybe some of you were having trying to do it quickly, last minute, or something. You just wanted to record something and get it done with, but that would result in very poor tracking results because the markers are just skewed, right? All of you know computer graphics vision. When you track something, it needs to sort of represent the original shape or form that it's meant to be before your computer vision algorithm can track it. And since we're using something that's existing, that is not that state of the art, we don't expect it to be that robust. In any case, if your picture totally changed, obviously you don't expect your the algorithm to be able to track it. The other thing is that so that's positioning your QR code markers. Sorry. Some of you recorded the video without moving the markers, so I'm not sure what is I mean, you are free to record your own style, but since we are using markers, it means that you should make use of it fully to improve the immersion of your intended lesson, right? Since you have stuff that can be tracked, then you should use the that whole mechanic to in the best way lah. That means to move the markers around at least, okay, to show that there's some interactive element happening in the video. Okay, so that's the other thing that was a bit odd to me, that you just place the markers on the table and then you don't move it, you just point to it. Okay, not very interactive lah, especially when you have the when it's meant to be lah. All right, that's why you're using printed QR markers on paper. Okay, this one is just some obvious things that it shouldn't happen. Inaudible sounds. The video sometimes are not fully. It just got cut off halfway. Very poor quality. Rather resolution video. I know it. I'm not expecting everybody to have a nicer camera, but if you look at the graininess of the video, again, it affects the the capture quality lah. And for those of you who asked us to borrow webcams, we did lend you. All right. Okay, so at least make some effort lah, to, if you find that you see the video is not coming out correctly, it will certainly affect later your next step. And you are free to record 100 times of your video for your B requirement submission. Okay, but this is just for us to determine how you guys have tried to do it and offer you some advice, okay, which may be obvious to some of us, but maybe not to the rest. This last point, again, it is with nothing to do with the specific content we are learning here. It's a matter of checking your submission, right? Some of you have the either missing video, you did not realize that you did not push to the repository, for example, I believe, or the video doesn't even work. So as if anything that you submit means something valuable to you, like maybe your grades, okay, you would check your submission, right? If whatever platform it is, if you submit on Moodle, you submit on any code submission platform, after you submit, you certainly go and download again and try it. Okay, so to me, yes, if I was submitting something on GitHub, of course I would go to the website and look at the file actually being reflected there, if it was of any value to me to do that checking. All right, if I did that, if I'm super familiar with GitHub, I will still do it. I will still go. I mean, if I'm super familiar with how this whole Git VCS version control system works, I'm fairly confident. But if it was a submission that I'm being accessed, I would still go to the website and check it. I'm not sure what, maybe something will go wrong, networking or otherwise. Okay, so that's that. That goes for any other files up there, because I do find, like in this last set of points over here, some of you have no build files, even when we ask you to furnish that after the submission deadline. Okay, JavaScript files which would just look wrong. I think they were the wrong build files, which resulted in your HTML file being empty. That means it doesn't display anything because it referred to a JavaScript file that is empty. Okay, so all this, it should not happen, lah. Yeah. Since I'm at the files part, right? Some of you also have duplicated files, duplicated folders, multiple versions of the same file with a slightly different name. So I'm not sure what's happening there. You are submitting something to be accessed, right? Of course, you would want to show it in the best manner. Otherwise, you're just showing people that you have not really finished, polishing your submission. Okay. And once I see that, I will go and look for other errors. I immediately see that, okay, there is something wrong with this submission. Let me go and find what else is wrong with this submission. Okay, so these are just general things that, whatever we're submitting, whether it's for this module or not, should be taken care of, right? Which is also, why I made the A set of submission, more of a setup thing, just as a chance to establish also, some of these things, which has to be done right before you even delve into the actual meat of applying the knowledge you learn in here, to building anything. Okay. So README, I think I've already mentioned this in the last lab. So I think there's not much of a need to repeat this. One thing that I realized also is, some of the instructions there appears to be ChatGPT output just pasted there. So of course, please do not do that, because as we know, as you use more of ChatGPT, it's good for, establishing some ballpark of what you're trying to do, but it doesn't really give you the exact outcome that normally what we want it to do, whether it's writing an essay or writing code. Okay. If you just cut and paste from there, it's pretty obvious. To a person who is trained in whatever area that is. Okay. So please don't do that. The last point that was not mentioned in the lab is this: after grading or looking at all your repositories, there's certainly a quite an obvious trend that those of you who are in the same team, okay, this is individual submission. I'm saying, yeah, you can work in teams, obviously, but it's overly similar. Okay, all your problems are the same, which I leave it as is, since most of you who have very similar submission, similar code for that matter, have problems. So that means you copied the same problems over, which I'll just leave it as you got your marks deducted, right? But just saying that, yeah, this is still an individual submission. Okay, please work in teams to figure out how to do it, but not, do the same thing. All right. Okay, that's all I wanted to say for the submission. So a few questions from Yongli. I know you DM me, but yeah, I think it would help others as well. Yeah, I know the problem. As I mentioned, I understand the practical issues of having the camera pointing directly downwards. Okay, but if you can't make it track the markers, I think that's a bigger problem. So certainly we need to find a way to directly do it. And I've seen other students who just hold the card up like that, right? Which also works. Just do the lesson like with the camera facing you. That's fine. That's more important to establish, right? The markers are being tracked for this task here. Okay, rather than a compromise and then the thing doesn't work. Okay. Continuing using the same repo, yeah, that's certainly fine. and expected that it should be the same repo. You submit for the IPA B criteria, right? It should be the same repo. Just continue working on that same one. And by the way, for the previous repo, when I was grading, some of you already have updates, which I can immediately see easily, and I will just check out the version that is before the submission, the second submission date, which means the date where we asked for you to furnish the build files, right? The dist folder. Okay, so I mean, you can just be rest assured of that we are seeing the right submission, and the reason why we're using a version control system is also that we can easily jump around, okay, and know what you submitted at which point. Okay. All right. So yeah, just make sure that you look at this and your own feedback as well once we send it to you. Okay, and just let us know if you have any issues. Okay. So let me just start the Mentimeter. Okay, and share the right screen. Okay. All right. So as usual, just join. Hold on. Let me just. The interface sometimes doesn't pop up. Yeah. Okay, a bit of a recap. What you saw in the video. Hopefully you have seen that. We spoke about interaction this week. Okay, and we tried to structure the content in terms of some common mechanics that you will find, and will need to decide on how to implement them with regards to the hardware that you have or want to create, okay, depending on your resources, obviously. So yeah, we started off with that mechanics, and then we also spoke about another dimension of thinking when you are trying to design for immersive applications, which is how authentic or what kinds of authenticity that you want in terms of your interaction. Okay, so yeah, I keep showing. I just had a big reunion dinner with some of these ex research engineers. So this is Edmund, one of your ex seniors, okay, from DigiPen, who helped us implement some of the stuff that you saw in this project, which is the locomotion research work that we did with LTA. So interaction mechanics is what I'm trying to talk about here using this picture. Some of the common things that you see here are all spoken about in the video, including viewpoint control, which is basically allowing a person to look around the world freely, which is deemed to be one of the most essential things when building such applications. Okay, and what defines the difference, okay, when you talk about developing for XR or immersive applications in general versus other forms of application. So I open up a few things just to highlight. Actually, if you look at oops, sorry, I pressed shift while clicking, so it opened in another folder. Some references which I have referred to are here, and if you look at what Professor Pan, who created this very popular introduction to VR module. As also mentioned, she did quote, the original person, Fred Brooks, okay, who defined VR, okay. This is just a transcript of this video. And yeah, I mean, this is certainly a good online alternative or auxiliary content that if you find time, you can go through, all right. But it's pretty introductory and not that focused on implementation, but still pretty useful in terms of design. Okay, but just pointing out that this is some of the things that I referred to, and what I'm talking about over here. She also mentioned that viewpoint control, one of the most essential things that makes a difference, right? Once you are in a digital experience, that if you look around in the digital world, you can freely control where you want to see things. That sort of defines immersive application. Okay, so other things that are defining that this kind of software application, right, is the ability to use hand gestures to do things, as well as to use other body parts, other parts of your body, and perform different gestures. Okay, like kicking if you are creating a soccer game, or if you're in any form like Fruit Ninja or something, you can use your hands to slash the fruits. All right. Other things that you see here are also on admin is this waist tracker. All of these are the same Vive trackers that we have used, okay, for the commuting simulator. So the chest one allows for us to track direction. Actually, this is purely for directional tracking. Because when we move the head around, right, if we walk, we certainly don't want to walk in the direction of where our head is, because sometimes we want to walk straight and look to the right. Okay, so which is why we needed this additional tracker over here. Okay, for this full body implementation of the system. Okay, and similarly, the legs and the arms, the hand trackers, we cannot confidently always use them to track the direction of travel. All right, so just telling you some of our considerations why we put so many trackers. Okay, just to do like infinite walking. Okay. Okay, next. So in this week's video, we also spoke, one of the key things that we spoke about is the authenticity, as I mentioned a few times now, is, when you create a certain interaction, like picking up an object, you probably want to think about how natural you want it to be, or how artificial you want it to be. So either natural, aim for as natural as possible, which is the most common thing when you first want to do a simulation of the real world. Okay, but often whether it is establishing or creating alternative experience, because you're in VR, right? If you're creating a game like in Super Hot over here, which some of you tried when you came to our lab, or you have tried on your own, the notion of or the ability to control time is something that is really interesting as a game. All right. So therefore, these are things that you may want to think about when designing for some of these interactions. Yeah. So magical interactions is one of them, like this, totally artificial and not possible in real life, as far as we know, according to what we know in physics. Okay, or you may want to augment, some natural interaction, as with the example I showed when I was talking about it in the video. With Half-Life, Alex, the gravity gun is old stuff, right? In Half-Life, Alex, the VR version of Half-Life, there's a gravity glove, okay, that turns your hands into things that you can pick up objects from anywhere, like telekinesis. Okay, so this is a way of augmenting the natural interaction. It may be also just as simple as, if you were in the VR, using the VR commuting example here, increasing the speed artificially. You're walking, but you are able to let the user control his speed by, pushing up the thumbstick, for example. This is also a way of virtual augmentation of a natural motion. Okay, the natural motion or the natural interaction being walking. Okay, but you make it like much more powerful. It's like giving a superpower to the user. Okay, so these are common things that are being done right now. Okay, in most VR applications in some way or another. So I think just presenting it in this week's content is a useful design element. Okay, whenever you want to create these things. Okay, first question. Let's see how far we go. I am hoping that we will finally end earlier. Okay, because I want to return some of the time that I took from from you all when we spend more time than scheduled. Okay, any issues entering Mentimeter? I'm just delaying time a bit because some of you it may not open up, whatever you use for this session. Okay, open up your browser, open up your phone, or whichever that you normally use to answer the questions here. Okay, I will start in 5 seconds. Okay. This is like a fact. Okay, but still need to fact check you guys. Okay, which interaction mechanic is commonly deemed to be the most important? That means every immersive application you create, almost surely, you will implement this interaction mechanic. Or do you find everything is equally important? You can also choose that answer. Wrong. Not everything is equally. Okay, so I'm not saying that you will. If you intend to make it all important, I'm not saying that you are wrong. Maybe for your specific use case, you want to aim for that thing to happen. Okay, but just based on whatever is covered in this week's content and what I mentioned just now, that viewpoint control is sort of like the defining experience. I mean, the defining mechanic, or the mechanic that defines a XR experience or immersive experience, that you give the user the ability to freely control his viewpoint and sort of have the free will of seeing this open virtual imaginary, maybe not imaginary, but open space, right? Okay, so that is sort of like a defining thing. Okay, which is what we are trying to tell you guys. Okay, again, not asking you all to follow this viewpoint. Sorry for the pun, but just saying that this is commonly what is perceived, in this space. All right, which is a fair argument to make, and it is also something that we can use, to as a way to anchor what we are building, a way to frame, what is the difference that we are trying to make here when we say we are creating an immersive application in terms of down to the implementation, is that at least we give the user the ability to freely look at things. Okay, as free as you can make it, the more immersive it will be, obviously, and as closely intertwined, or rather closely associated, correlated with the natural action of the user, obviously that would increase the immersion. But we're not talking about the the actual action of the user when we are saying the mechanic. So we are just trying to say, what are you aiming to achieve as outcome in the experience? How much you can achieve is another question. Here is what you're trying to achieve. We are trying to achieve viewpoint control. Okay. So I have shown this thing in the video. Okay, and it's also one of the projects of one of our old projects we listed on our website as well. So here we will just watch a bit of this so that you are forced to know what we did in the Center for Immersification. No, that's not the main reason, but just as a way, for you to for us to revise content. Okay, so this is a VR bioreactor. A bioreactor is the thing that you see on the right over here, which is a replica that we tried as far as possible to recreate. This was handmade. We didn't use any modern technology to LiDAR scan or anything. Okay, because it needs to be highly interactive. Okay, so every model in here are all handmade from scratch, and the key thing is not the models here, but the interaction that we created here. And a bioreactor is this very expensive equipment that your friends at the pharmaceutical engineering have to deal with. Okay, have to learn how to operate in the first instance, and obviously use that knowledge to apply to many different things. Okay, so as we understand, not everybody in the class, especially as SIT grows much bigger every year, not everybody in their class can have a chance to work with all the bioreactors. There are many different versions of this, so VR was a natural solution. Okay, especially when there are some dangers associated with it, as well as there are some costs if you break stuff, and very high cost. The plastic bag that you saw, if you have seen this video before, rumored to cost like in the span of 10K if it gets spoiled. And it's not that easy to spoil, not that hard to spoil the plastic bag in there. Okay, so yeah, just for you to observe the kinds of interactions that the students have to do in VR here. We are not replacing the real interaction. Nothing beats the real thing, obviously, with a machinery as complex as this, and with the limitations of physical hardware to replicate virtual actions. Okay. But our intention here was certainly as real as possible, as you can see, we are constrained by the controllers because we just do not have resources to create new experiences back then, and there was no real robust hand tracking back then when we created this, which is already, when we ended this is around 2 years ago. Okay, when we started it, it's around like 4 years ago, 4 or 5 years ago even, depending on when the start point you want to think about it is. Okay, so if I skip this a bit, yeah, it's just, setting up the bioreactor, operating with some of the stuff on the site as well. There is, some online GUI slider thing that we are using as proxies to the actual stuff that they need to interact on the screen because it was too small, and so on. Okay, so let's go on to the question. Okay, again, just to check, that we are on the same page, and you are using the same terminology as what we're trying to establish here. Just asking you what mechanics, interaction mechanics you see in there. Okay, so there are no body gestures. Okay, I'm not sure if those of you who chose all of the, oh yeah, so all of above means that you include body gestures. I would be curious, what do you see there in there that is a body gesture, or what do you think that we wanted to do with the body? yeah, just let me know in the chat that resulted in you choosing, the answer which includes body gestures. I didn't expect two answers to be correct. Well, no need to do too much of a strategic, sometimes over trying to think about the MCQ strategy may result in it being wrong. So, um, yeah, one thing that I try to differentiate. Okay, the terminology, I know it's not like the best word to refer to the things that we mentioned in the video, okay, but there are basically three categories of interaction mechanics that we try to categorize. Okay, the first one being viewpoint control, the second one being hand gestures, and the third one being the rest of the body, excluding the hands. Okay, in normally when we say body gestures, yeah, it can include the hand lah. But here, just for question answer sake, okay, we will exclude the hands for this answer category over here. Okay, and for the discussion in the video also, we are just talking about how from the most important thing to the least important, not saying that body gestures is least important in all cases, but in most cases, the first thing you want to focus on is the viewpoint control. The second thing is, whether you allow for some form of hand gestures. And then the third thing is, other than hands, then you think about other things, which is also how the hardware evolution of hardware can be is right now as well. If you see most of the HMDs, certainly at least you have the headset. Then the next thing is that how good the controllers are, or rather what the controllers can do to mimic your hands. Okay, it was originally just normal click, trigger, button press controllers. Okay, then things like the valve index, okay, had some form of finger touch detection that sort of allows you to do some very interesting things. If you played Half-Life Alyx, you would know that it really opened up a lot of possibilities, okay, for interacting with fingers, although it is just trying to track whether the fingers are on there or not, or which finger is on there. Okay, then you can't come to real finger tracking. So you can see the focus is always is currently still on the hands. Then after that, people would then think about other body gestures, using other parts of your body to do stuff in VR. Okay, so just to highlight that this is the order of how immersive applications has evolved, and also highlights the importance of what you should focus on. But here, and in different use cases, you would have to include different things. But just saying that in the absence of unlimited resources, sometimes you have to go with the flow, right? Which is what the hardware provides. In this case, both of the answers are correct, okay? Because I had the limitation of Mentimeter, no multi-select questions, but you know that if this was a quiz on X site using the lockdown browser, okay, we can certainly have multi-select questions. So be certainly aware that you should choose both of them, okay? If in a real quiz here, choosing either of them would be correct. Okay. When is the quiz? Yes, next week. Okay, so the first quiz is next week. The assessed quiz is next week. That's according to the schedule. Maybe I should jump to, since you have a question here, right? If you look back, I'm not on the right screen. I'm trying to click on the projected screen. Okay, let's refer back to the schedule. Okay, so what am I clicking? Schedule at a glance. I did mention the last time there was some changes, okay, according to our progress, okay, which maybe it's a good time to highlight right now. So we are at week 8, interaction. So week 9, as scheduled, this didn't change at all, okay, from the onset that the first quiz is next week, week 9. Okay, and then following the quiz week, which is also the revision week, which I find it will be essential that we recap everything that we have covered, okay, and consolidate that knowledge, as well as give you some time, to work on your IPAB, right? The following week would be the submission of IPAB. This one got shifted 1 week late. Originally I put it in week 9, but I find that it's probably too tight. All right, and also that the implementation. This will be a live stream with Songjia, okay, in week 10. Okay, so we will just go through some of, just like the last time before the break, we had a live coding stream, okay, to talk about creating the virtual environment. So this one is just the other version of creating some common interaction elements with the web-based interface that we have required you guys to work with. Okay, so that is in week 10. Then after that, week 11 is a metaverse lecture, more of social aspects of creating immersive applications, multi-user, social, and this whole concept, which is all the buzzword right now, all the buzz right now. Okay, so just having a session on that. And then after that, we'll have a guest lecture from our NVIDIA friend, Meg, who will talk about some of her work, okay, in relation to creating immersive applications. And finally, the last week we will have the final quiz and revision appropriately. The final week we revise everything with a quiz, okay, and the team project submission. So that's what's going to happen. Yep. So Ryan, that is correct. IPAB is due that Sunday. Okay, let me just scroll through some of the questions in the meantime, since we're on questions. Okay, I see that, most of you who answered wrongly here either have trying to strategize, or rather due to the fact that Mentimeter doesn't have multi-select, you thought that it should be something else. Okay, so that's fine. I mean, that means it's nothing wrong with your, not much of a thing wrong. Not sure, that sentence sounds wrong. So that's, not so serious. The problem is not your understanding of the content. It's more of the platform that caused your problem of choosing the wrong answer. Okay. And the exclusion, some of you, one of you mentioned, Sean. Sorry, not Sean. Matsu didn't see the excluding part. Okay, that is also fine. Solomon, the quiz is during the lecture session. Yes. All right. The lab session would still be the lab session. Yes. So the lecture session, we will. So I will, send out an update, but most likely you're going to have the first 1.5 hours of quiz, and then the second 1.5 hours we would immediately revise the quiz. Okay, so that's the plan. Okay, if there's any changes to the plan, I'll let you guys know. Okay, and the format would obviously be the lockdown browser format. So I assume that we have mentioned that enough times that you should have already done that, which I see, I think most of you have. Okay. All right. Back to this. Okay, so I think it's clear. There's no body gestures. It's just viewpoint control and hand gestures. Oops, where is my... Okay. Next question. Hopefully you all are back on your Menti screen, whatever device you're using. Okay, now I'm trying to ask you something that was mentioned in the video, and I think it's worth highlighting. Passive or active? Again, when you're implementing an interaction, it's also a good thing to think about whether you are actually trying to do this to allow for the user to consciously do something with it, or unconsciously, or subconscious, not subconscious, that's the wrong word, unconsciously, yeah, I also wrong, but basically just, use this interaction without thinking, deliberately thinking about it. So that's passive. So, which is the right answer here, that, most of the interactions are not, like, I'm not asking you to, use your viewpoint to do something directly. Maybe indirectly, you have to look at stuff, obviously. Yeah. And in general, viewpoint control is commonly passive. All right, it is just something that the user assumes that can be done whenever you don a HMD, all right, or whenever you wear a AR glass. You are sort of expecting that I can view things freely, right? So, AR glass may be a bit too obvious that AR is meant to be looking at the real world. So certainly you want to allow the user to look at the real world. But sometimes we as developers, we sort of forget that, and the whatever virtual stuff we implement in there, we didn't take into account that people can view anywhere. Okay, and we just do it the wrong way and produce the wrong kind of experiences. Okay, so as I was completing my statement, when you are designing, implementing a certain interaction, it's good to think about whether you are designing it to be passive or active. I've just explained passive, okay? Not directly wanting the user to consciously think about using this mechanic to do something, okay? This mechanic here being viewpoint, but the user sort of has to use it, to do other things. So active means that you create this mechanism, like picking up an object, as a way for the user to actively or consciously, deliberately use that thing to achieve some goal, all right? Okay, which, if we look at the VR bioreactor, I hope it's obvious. Oh, sorry. What the active one is. Apologize for that. Keep clicking on the wrong thing. Yes. So next question. I think I almost revealed the answer, which is why I am stammering. Okay. Explain too much. Okay. So just now asking about viewpoint control, passive or active. After the explanation, hopefully you will choose the right answer. In this case, I'm asking about the hand gesture, whether it's passive or active. Yay. Okay, I hope 3 of you just your finger slipped, okay, and clicked on passive. Okay, I think I've already explained the answer for this. But if you are having issues understanding the concept, obviously just ask. Okay. Okay, now another thing that we have done, or I have done previously, is this thing which I have shown before also, this 360 video, which is a web-based experience. Students can just browse around freely. And when they reach this point, they have to focus on the door for a while for it to trigger the click on the door. Similarly, this is still 360, you can view anywhere. And then at this point, actually the user has to focus on the projected screen in order for him or her to trigger again, going into the actual lecture content. Okay, so this was something that we created previously. Whoops. Why did I exit? Oh, let me just go back to the right format. Okay, I clicked like 5 times before it can go into this view. Okay, continue. Question. So that was the experience. which can be viewed on anything, desktop, Google Glass. So not Google Glass, sorry. You want to view on Google Glass also can lah, but um, I meant to say Google Cardboard, or you want to put it in the Quest, or up to you. So that works anywhere because it's just a web-based implementation. Okay, so now for this application, what interaction mechanics? Okay, good. Still, some of you are choosing the other answers. Not sure why. Yeah. And you may be wondering, hey, how come this is still correct? It's not by an error on my part. Intentionally also included that because if you carefully watch the video this week, right? If I go back to that slide, just to have a picture. Oops. Wow, this is lagging by a lot in terms of navigating the Mentimeter slides. Okay. Yeah, and if you, as I was saying, if you look at the video carefully, I would have mentioned that this gaze control mechanism, right? That means using eye gaze to click stuff, like even in our immersification .org web page, right? This is also that mechanic that's using eye gaze. Oh, my models are always lagging. Why is it not loading? Too big. Okay, but anyway, that's the house is not important to be loaded. Yeah. For what I'm explaining here. So you can see the blue thing is the where I'm gazing at or looking at. And if I pause there long enough, you can see that it shrinks, right? So this is a common visual feedback. And not common lah. This is just what we implemented. It may be, you know, the highlight becoming darker, whatever. Okay, just to show that a click is happening. Or it may be even some of them have a time meter in the center. Okay, just to show how much more to go before it becomes a click. All right, all this probably you are already familiar with if you are toying around with some existing web experiences out there using your Google Cardboard that you took. Yeah, so if I pause here long enough, it will become a click and I will click to the appropriate website. Okay, so that is eye gaze interaction. And this action of clicking is actually not viewpoint control, right? So again, you know, whether we are talking about viewpoint control mechanic or hand gesture mechanic or body parts mechanic or other body gesture mechanic, we're talking about the intended interaction. Okay, so the intended interaction for here is actually the natural interaction of clicking on something, okay, or touching something. I want to touch this button over here. Okay, so that's the intended interaction, which is natural. That's a natural thing that we always do, right? To touch something and then activate. Okay, so but the way to implement this, the way it is being implemented in a cardboard experience or this web-based experience is that it is using the viewpoint control. As I mentioned in the video, it is like making the viewpoint this ability to, you know, view things, right? Doing double duty. The first duty is obviously viewpoint control. Okay. The second duty is hand gesture. So this is like a point, click, or touch, click, touch, activate kind of a hand gesture. All right. It is not viewpoint control. This particular interaction over here. Yeah. So that's the thing I wanted to emphasize with this question. Okay, that actually we're implementing two things when we do this this eye gaze component. All right. Any questions? I hope that doesn't confuse you. Okay. Wow. All right, which is why both the answers are again correct. Okay. You know that just saying again, not saying that it will come out in the quiz or anything, not saying anything like that. That if this was an actual question in the quiz, I would be expecting you to check both answers. Then you'll get it correct. If you check one answer, it's still wrong. Okay. Okay, next question. I'm asking specifically the viewpoint control. Passive or active? Okay, the correct answer should be active. Okay, but I allowed for this just as a free, since this is like a not assessed quiz, right? Because it's debatable, the word viewpoint control, whether I am referring to it as a implemented component, okay, or I'm referring to it as a interaction mechanic, okay. So if I strictly speaking, if I referring to it as an interaction mechanic, then I would, only allow for the answer active, right? It's an active, sorry, passive. What am I saying? If I'm only thinking about the viewpoint control mechanic, sorry to say the wrong thing. Yeah. If I'm only talking about viewpoint control as an interaction mechanic, okay, then it should be passive. All right. I'm still just looking around, right? But if I'm talking about viewpoint control as the hand gesture, right, then it is active. Okay. So just saying that I would obviously not give such a controversial question, okay, in the actual assess quiz. Okay, but I just think that it's useful as just another dimension of thinking when you are designing for such interactions. Okay. Hanif, I will not give this question in quiz. That's for sure. So, sorry, Solomon has a question that all viewpoint control are passive, all hand gestures mechanics are active. Okay, so yeah, for the purpose of what we're discussing here, that is almost true lah. But I'm just thinking now that if your viewpoint control is meant to be a certain action, that means in your VR experience that one of the goal is for the user to stare at something for it to to explode. Okay, so that becomes active interaction mechanic. So viewpoint control, I think strictly speaking, doesn't have to be always passive. All right, most of the time it is passive, but there may be very unique examples like what I'm saying over here, that the the core mechanic, the core interaction in your game, for example, in a VR game, is to stare and make things explode. Okay, then obviously this viewpoint control interaction mechanic is an active thing lah. Okay, it's meant to be an active thing, and you should probably implement it in somewhat of a different way. Actually, it's quite similar to gaze control. Yeah. Okay. Next question. I have no idea what I'm asking next, so let's see. Okay, still at the same example. What form of interaction authenticity? Now we move on to the next concept. So this ice gay point and click thing, what do you think is the authenticity? I think I've also sort of explained this, but understand that this is sort of a concept that we introduced to most of you here new. So it's fine if you got it wrong. Okay. It's just, again, another design tool, okay, in a way that is good to think about when you are implementing such things. So remember, authenticity means you are deciding whether you want all out it to be the same as real life, the intended outcome. Sorry. Or you want it to be, you want to be creating something that is impossible in real life, or you want to augment something that is possible in real life but making it more powerful, which is the third option, the correct option over here. Because again, note that the intended interaction outcome is a natural click and touch. I mentioned this just now as well. You may argue click, is that a natural thing to do in real life? I would argue it is, because we are dealing with point and click stuff on our computers always. Okay, so it is something that is possible in real life. And if you're thinking about touch and activate kind of a interaction, if you describe it that way, it's also something that's natural in real life. So it is a natural interaction. So that's the first thing to clarify here, that we are trying to implement something that is commonly done, or that is possible in real life. Okay, this click touch thing, click touch to activate or to do stuff. So that is clear, I hope. If there's any questions, let me know of my explanation. And then the next thing to ask is, are we doing it totally matching, what we are doing, like mouse click? Are we trying to match that? No. So we can see that we are trying to, be able to click something like very far away in our virtual space, right? So we're extending that with a laser pointer thing, okay? Or it doesn't have to be a laser pointer. In fact, if you look at here, right? Sorry, where's my pointer, mouse pointer? Again, the example of our website, there's no laser pointer lah, but I'm just I'm able to click on things very far away, right? I don't have to go there and try and touch it, have a proxy to touch it somehow. So this is what we mean by augmenting the natural interaction. Natural interaction in this case is, you need to click on stuff, okay, but or you need to touch and click on that button. All right, this is the VR simulation, right? So we're augmenting it with like the ability to do it at a distance. Okay, so that is why this is the chosen answer. I know it is slightly, I mean, that is quite nuanced lah, this kind of a thinking, but I purposely put this here to be able to explain this lah, in terms of how I'm viewing it. Okay, so again, not really asking you to always do it in the same way given the same use case, but just presenting some possible angles of thinking about implementing interaction. Okay, that's useful whenever we create stuff in immersive applications. Okay, next question. Okay, so this is describing a certain use case, which has been described before. So VR application to allow kids to learn physics in a classroom. Physics, real physics. So we are creating this experience where the users or kids will be able to throw virtual balls, hit the cans, and hopefully look at how the cans fall, okay, and how the ball interacts with the cans when they throw it in a different manner, different height, different force, different projectile. Okay. Yes. So thinking about that kind of a goal, right? What is the authenticity that we should create? Yep. Yeah, I would think that it is natural. Okay. Firstly, artificial, magical means that. So for those of you who chose this intentionally, I think it is, wrong in terms of what we are describing here, because again, magical is something that's impossible in the real world, as what my use case has been describing, right? We are trying to teach kids physics, throwing a ball, hitting cans, and real physics. I'm wondering, why do we want to have interaction that is not existing in the real world? Like if you're thinking about creating a ball of fire, for example, to shoot at the cans. So that would be a magical interaction, right? Which we are not. There's no motivation to do that given the use case here. So really, we are trying to create something natural. Naturally throw a ball. Naturally, the environment interacts according to physics. Since we are trying to teach physics, okay, so this ball throwing needs to be aligned well with real physics. Okay, the last one, we are also not. We have no real motivation to augment, like the action of throwing. We don't need to, like, using gravity gloves to pick up the ball and shoot it at a super high speed. So we don't want to do that because we are trying to teach kids real physics. Okay, so there's also no real need or even no motivation, to create that kind of interaction. Okay, so that's why it should be natural, okay, given the circumstances here. Okay, next question. Not sure why they cannot make the picture bigger. Okay. So this is somebody wearing HoloLens interacting with a virtual dog, which is what I'm trying to describe here. Okay. MR application for people to practice taking care of a dog, okay, before them actually hurting a real dog. No, so this is, I said in here as a way for people to understand, all the nuances or the intricacies of taking care of a pet, okay, before actually owning a real live dog, okay, in the future. I should probably patent this. I'm not sure whether anybody has made this. I just created this idea out of thin air. So maybe this is a good business, venture to go on next time, right? Okay. Anyway, also interesting distribution of answers. Again, I ask of you to explain, why you chose the wrong answer, since there's a fair amount of people who chose that. But let me explain my thinking first, which is, once again, this is something, this use case as described is a form of training that we want to give to a person, or form of experience that we want to give a person to understand what it takes to take care of a real dog. I did mention in the second part of the first sentence, right? To help them with the decision of actually getting a real pet dog in the future. So again, there's no real motivation to create anything magical. We don't want the dog to be able to fly, or we certainly don't want the dog to be able to eat like tons of food without getting fat, for example, or we don't want the dog to not poo, okay? We want the dog to do things like in real life. We want the dog to be able to maybe jump onto the table. This is MR, right? To understand the environment, jump onto the table, and so on, and not like pass through the table. That would be, or pass through walls, ignore collision, for example. We want the dog to be able to understand the environment and route around the wall, and so on, okay? And not do anything magical, because as described over there, it's to help a person make the decision of getting a real pet. Okay, similarly for the augmented natural interaction, we also don't want to do that, like what I mentioned. We don't want the dog to be able to jump on top of a HDB flat, right? Okay, that will be like augmenting the ability of jumping. Okay, it may be fun in a game, but here, given the use case, we are trying to mimic the real experience of owning a dog. Okay, so yeah. Thanks, Daryl, and thanks, Matthew, for asking the question and for the answer. Yeah, so the answer is correct. Yeah. Okay, next. Okay, now a bit of a few questions on hardware devices. The question is, I mean, the use case being depicted over here is a VR training system for aircraft maintenance engineers, aiming for maximum immersion. Means this company has unlimited resource, that has a good amount of money to spend on this. Natural interactions, to have a natural interactions as far as possible around a life-size virtual aircraft. So what device is optimal? Yay. Very excellent distribution. Okay. So the first thing that the question is trying to highlight, okay, that is important here is to understand what mechanics each device provides, which is actually the super common process of development, right? We sort of commonly depend on what is available out there. Okay, whenever we have a new client at the center as well, we always try to of course find out what the requirements are, and then very soon after the question will be what device are possible. Okay, because different devices cost different amounts of money, especially when the experience supposed to be delivered to a group of people, and then if it's like 100 students, the cost really scales up a lot. So stuff like that. Understand what mechanics each device provides, so that as much as we want to think that we can, as researchers, we can create all sorts of hardware that is meant for the right experiences, the reality is that nobody has infinite resources. So and people always have a strong need to serve the as common a population as possible, and to be able to um, you know achieve things in a shorter amount of time, which means not spend too much time like recreating new forms of hardware. Okay, so yeah, it's certainly important to know all the existing famous headsets and what they do, especially when you really want to become a software engineer in this space, or engineer in this space, or designer in this space. Understanding the famous devices is one important thing that you will need to keep up with. We us as well, our Pico 4 is coming in, and our Quest Pro is also hopefully arriving next week. Yeah. So having a good awareness of what the current devices are is essential. This the next thing, which more often, not more often, but the next consideration is actually more important, but sort of we are confined by the practicality of the hardware. What I'm saying is that, yeah, we need to think about what kinds of mechanics that the use case example actually requires, right? And since it is a aircraft training, a training for aircraft engineers, for maintenance, working around a virtual aircraft, I mean, viewpoint control is like a given that we need it. The next thing is hand gestures. Okay, so since it is maintenance job, obviously we want as much natural hand gestures as much as possible. Then we think about body gestures or other body gestures other than the hands. Do we need them? Um, you know, thinking about an engineer working on an aircraft probably mostly deal with the hands. Obviously, we want to talk to the client to understand much more about what are all the different possible interactions that they want to be trained in. Then we would fully understand. But just saying, assume that yeah, it's all hands. Yeah, we don't need to use the leg to do maintenance for an engineer around a aircraft. Okay, so that matches exactly with what MetaQuest and HTC Vive provides. HoloLens is already out of the question because we mentioned the word VR here and not MR or AR. Okay, which is what HoloLens is best at, and we want natural interactions. We know if you have used HoloLens before, you know it is not the best in terms of interaction. Yeah, sad to say, recently Microsoft also slashed a huge part of the team related to HoloLens. But anyway, that's besides the point. The main thing is we want as maximum immersion. That's also a key point. HoloLens is not maximum immersion kind of a device, right? It's more of a AR, MR thing. Okay, maximum immersion in the training means that we want to shut off everything and then just create an environment that has a virtual aircraft. Okay, so the reason why MetaQuest is higher than HTC Vive which is the correct answer is because I've mentioned in there a life-size virtual aircraft. So again, understanding what the device provides in terms of how the mechanics are provided. MetaQuest is wireless. I also purposely put wireless wired, right? Vive Pro, as we know, is commonly wired. It can be wireless, but it's not meant to be. You need an add-on and then make the whole thing very bulky with the wireless setup. And it doesn't work that well wireless. Okay, whereas MetaQuest 2 is a all-in-one or stand-alone headset that is meant to be wireless. It can also be wired, but it is meant to be wireless. So therefore, it is the better choice since the space to move around is large. Okay, a life-size virtual aircraft. You want it to be wireless. Otherwise, you sort of need to push a tattered PC around if you're using HTC Vive Pro. Okay, long explanation because there's just many factors of consideration when you are deciding on a certain device platform, which is important. Okay, with the knowledge that we know in terms of we learned this week the mechanics. Okay, next question. Yeah, Yongli, a real aircraft is also a device of choice, but it's not one of the answers. And in fact, not me, I'm not involved in that project with SMRT, which has decommissioned trains. Okay, and the decommissioned trains was actually used to create a MR kind of experience for training engineers. So that was a real thing. Yeah, so that will certainly provide even a more natural kind of interaction. That means overlaying virtual stuff to enhance working on real objects. Okay. Okay, another portrayal of a certain use case. VR cycling game, stationary trainer. If you don't know what a stationary trainer is, okay, VR. You in the actual quiz, right? You also can Google, right? Just saying. If you don't know anything that I mentioned in there, just Google. Yeah, it's a stationary bike. All right, it can be a real bike put on a stationary trainer, as you can see in our own example over here. You can look at your own phone now if you're reading the question. Yeah, this is a stationary trainer. Sorry, too small now. Yeah, this is a real bike on a stationary trainer. Okay, also one of our previous projects. Yeah, so the question is that you are supposed to implement this VR cycling game where you can put this player against real professionals, cycling professionals, elite cycling professional, not real, virtual versions of the real cycling professional in Tour de France. Okay, again, if in a quiz I mention things that are not familiar with you, just search, right? Even if you are using the restricted form of Google, which I put in there, which you can't click on links when you're in lockdown browser. You can still see what Tour de France is. Okay, it's just the competition of the year for cycling. Okay, the event of the year for just competitive cycling. Um, yeah. So I mean, we can safely assume that any user is not at the professional level, which is why I mentioned augmented natural interaction, right? So, what device is optimal? Well, the main thing is that when you want to do this, you sort of have to track other things. Again, viewpoint control is a given. This is a typical, VR experience. Then we go on to hands, right? So hand gestures, in a way we don't really need hand gestures, but the problem is because the hands are always on the bike, we don't need to gesture anything at all. So actually, is viewpoint control enough already? The problem is that there are other things to be tracked in a cycling experience, like if you are tracking the actual motion of the legs, okay, how the legs are paddling in circular motion, that's another thing to be tracked. Okay, you can put VR trackers on Vive trackers on there, or if you don't really need the actual you don't really need to understand the circular motion of the paddling, okay, then you can put the tracker on other things that are moving, okay, like for example the flywheel at the back of this stationary bicycle, okay, or you can put another sensor that just tracks how fast the flywheel is moving, and not a motion tracker, okay. But the thing is that you need to track other things other than just your viewpoint. And what is the system that allows you to do that, understanding what the system is? If you know what HTC Vive Pro is, if you don't, just search once again HTC Vive Pro tracking. Okay, immediately you can see, even without clicking. Okay, but let's just look at the full setup. Yeah, sorry, today I'm not in my lab because it's used for experiments. Okay, so I'm in my office, so I can show you the actual tracking setup. But you've seen that before lah, the lighthouse or Steam VR tracking is the word that's being used for that setup. So let me just click on images. Where is maybe lighthouse is a better word. How somehow it doesn't show. Yeah, so this whole setup with external trackers is what we need here. Okay, so that we can actually track other things on our body. Okay, rather than other than just hands. For the Quest, right? It can certainly also track other things, but it's just much more difficult to make it work. And if you do make it work, for example, with Vive trackers, it doesn't work that well with something that's built for tracking other things. All right, and especially when you have other things that are not in view. Actually, if you look at this, right, the essential thing, where is it? The essential point why something like the Vive Pro has to be chosen is because if you track the legs, for example, and you are using the HMD like the Quest to track your legs, it wouldn't be good, and it may not even be possible at all, because the tracking system is on your head, but the sensors is here, so the head tracking motion tracking system cameras cannot see your legs, okay, which is also why in our project, if I were to just use our other project as an example again, which is also why in this project we also had to go with this system. Although, um, the sensors are sometimes are mostly like in front of us or below us. Similarly, it's not so robust lah. If we use internally inside out tracking, as what they say for the Meta Quest Pro, it just cannot detect when our hands are swinging to the back. I'm saying cannot, but recently there are some machine learning algorithms that allow it to guess where your hands are because it just has some learning mechanism to do so. But it's just not the same as tracking the real thing moving to the back where your headset cannot see, but the external trackers can see. Similarly for the legs and stuff. So therefore, we need external tracking for such kind of use cases. And which is why HTC Vive Pro is chosen. All right. Again, long answer. Okay, but hopefully that gives you a glimpse into how we made some of the decisions here. Okay, and for you not to make the same mistakes if you join, if you're creating a startup, whatever, to create different types of experiences. Okay, so I think Jia Zheng, I hope that answers your question. And then let me see, Hanif is saying, because of the trackers, not direct. I mean, not only the trackers. Without the trackers, I mean, if you're talking about tracking the feet motion, the wrong picture I'm referring to here. Yeah, so if you're talking about tracking the feet motion without Vive trackers, it's also possible, right? You can do hand tracking, you can do feet tracking. It's just the problem of only having the headset, right? You cannot see the feet or other parts of your body robustly. Okay, if you are trying to track other parts of the body, you need a system that is intended to do so, like a system with external tracking. Okay, a system with the lighthouse trackers that can see other parts of your body. All right, so that's the main reason. Okay, so these are specific examples that would sort of require you to know what the system is. You need to know that Meta Quest 2, is not meant to see your other parts of your body. Okay, you need to know that Meta Quest 2 doesn't have built-in support for attaching a cycling tracker, for example. I mean, you don't need to know that. I mean, it's easy to assume that it doesn't have that capability, right? It's just too specific. All right. So we are not asking something that's I'm not asking something of you that is like needs very specialized knowledge, in my perspective. Okay. How many questions more? Okay, this is a video from somebody else. Okay, not my project. I just randomly searched for this. Just to highlight GUI. Okay. We got no time to watch this, so that's why I'm fast forwarding to the part where there is a GUI. So yeah, you can see one type of GUI implementation is like that, In a way, this is like an impossible, artificial, magical kind of a thing. Okay. But that's their choice of implementation. Okay. So in this week's video content, the last part was, using a typical interaction use case. Two typical interaction use cases, the GUI as well as locomotion. All right, two very typical things that you will need to implement in your immersive application. Okay, just as a way to see, what are the design considerations that you will need to go through when creating these common things. Every application would require you to do it in a different way, would likely require you to do it in a different way. Okay, so once again present a set of a set of scenarios, okay, for us to revise this concept. VR sightseeing, hotel guests. Again, this is like a real example from an interaction from an industry partner. All right. Virtual trips. A hotel guest, the client wants to obtain feedback after each virtual trip. So the client only has resources to supply Google Cardboards, just like how we only have resources in this module to supply you with Google Cardboards. So what form of GUI is best suited? There's 3 descriptions over there. Okay. So the 3 options are, first, GUI on virtual paper. That means in the VR experience, you actually have a virtual paper, then you use a virtual pen, and then you can sort of write on it as your feedback. The second option is, which is the right option, is the GUI on a 3D plane anchored in virtual world location. Sorry. Yep. And the third option is take off the thing and then do the quiz. All right. So the virtual sightseeing, experience. Firstly, gaze interaction will be pretty fatiguing. That means it actually is pretty tiring to do it in VR. Oh, okay. Sorry, I think I this question, the answer is wrong. Apologize for that. So, yeah, the answer for this one, should be take off the thing and do the quiz. Because, as I mentioned, this use case, the client only mentioned can only use Google Cardboard lah. So if any form of GUI in there that requires you to finesse around, the gaze and then answer questions, it would be just too much. All right. So the actual the right answer should be to take off the thing and then take the quiz. All right. Let me just check my next question to see whether, I think I mixed up the answers for the 2 questions. Okay, give me like 1 minute to just check. Okay, indeed. Yeah, I mixed up the question. But anyway, I will skip the next question. Okay, maybe the next question will appear in your assess quiz. No, I'm just joking. Okay, not trying to give any hints. Okay. All right, but I hope you understand what I'm trying to explain here. That the evaluation, even if we say that we want the virtual sightseeing to be somewhat immersive, okay, given the constraints of Google Cardboard, and we don't want to like pull people out of the experience, but still the problem of interacting using gaze on a GUI, whatever form the GUI takes in the VR, it's still too much of a pain. So therefore, we certainly wouldn't want to put people through that pain, and it would be even more intrusive, or rather obtrusive in VR, okay, to do that quiz. And this would take people out of the immersion even more, okay? When your original intention, maybe you want to think about, you want people to continue, the immersive experience and not take out the goggle, right? But in fact, if you require people to do something that that problematic in terms of usability, using eye gaze to pick MCQ questions, or to using eye gaze to scroll through a selection bar, okay, those are just too much. So therefore, certainly we wouldn't want people to do that, given a Google Cardboard. Okay, let's go on. Okay, here is a video of something that I shown in this week's video content as well. This is called the locomotion vault. Actually, there's no need to watch this video because I was just opening it just now. Oh, here. Okay, so this is the actual website, which I think is a good way to highlight just how much of work is being done in this single interaction use case, the locomotion. There's so many ways to do with locomotion in here, which, and there's so many different dimensions. And you can see people use the same words. Is it a magical form of locomotion? Is it not? So these are common terminologies that are being used. But, you can have a look at all the different ways people are dealing with locomotion now, because it is just such a big challenge, which is also why we worked on that challenge as well in our last paper. Okay, so let's not waste any more time. Sorry that this we couldn't end much earlier today as well. Okay, let me just go on to the next slide. Last two questions. Okay, VR game for people who are on wheelchairs. Okay, to explore famous mountains. Okay, there's no other information given here. Just asking you, what locomotion technique is best suited? Okay, good. I mean, the first two should certainly be the best choices. For walking in place, right, and which is what we did in our last commuting simulator paper, whether it's on a 360 treadmill or it is using trackers, which is exactly what we did, okay, in that locomotion paper, they would not be correct because I'm talking about wheelchair, right? So tracking real movement in physical space. So anyway, if you're talking about like wheeling in place, that's possible. Of course, 360 treadmill is almost out of the question unless you're talking about creating a wheelchair simulator, which in fact we tried. Okay, in that locomotion paper with LTA, sorry, one of our requirements was also to explore wheelchair users. All right, we tried to create a simulator, but we didn't go very far with your engineering student friends from other programs. Yeah. We didn't get very far with that because it was just too complex. I mean, the amount of mechanical parts and safety considerations that go into such a simulation is just too much. All right. So that's certainly not the answer here. And in fact, this is not talking about that. And using trackers, we also tried that, put trackers on real wheelchair wheels, which actually works. But the problem is that the viewpoint control is mismatched with, the direction of travel. So unless you can simulate the wheelchair to turn to the right direction where you are moving in virtual reality, you would get crazy amounts of cyber sickness. Okay, so because when you turn in the virtual world and your wheelchair is still fixed, right? And imagine you are turning a curved line, a curved a line of travel. And then in your view, you are keep turning, but in reality, the wheelchair is just going straight, right? Or it's just on a stationary bike kind of a setup. it would cause a lot of cyber sickness. The mismatch between reality and the virtuality is the most famous way of causing cyber sickness, as described before. Okay, so this wouldn't work. Now, this one nobody choose. So obviously, tracking real movement for scaling mountains on a wheelchair is just not correct. I mean, that kind of interaction. Okay, so now the last two, teleportation and joystick base. The reason why teleportation is better, because joystick base is actually famous for causing cyber sickness, especially in this scenario. Again, we also tried this. Sit on a wheelchair, real wheelchair, just to get the feel of it being the same. And then we have a joystick that made to feel like the joystick on motorized wheelchair. But the problem is that, again, if you move the joystick forward and the wheelchair is stationary, that's one thing already. That's a mismatch, but it's not so big of a mismatch. Once you turn, that's where a lot of cyber sickness would be induced, even for people who are super experienced in VR. Do VR on a daily basis, you will still likely get the cyber sickness because the mismatch is just too great here. All right, especially on wheelchair, because you're moving at a certain speed, expected to be moving on a certain speed on wheels. Okay, so that's why teleportation is the best choice. Okay, sad to say. I know teleportation is like a magical interaction, which is not similar to real life in any way. But we didn't give that requirement. And in fact, this is a virtual sightseeing experience, right? So we're not saying that it's a virtual hiking experience or anything like that, that will require you to move slowly through the mountains and experience the length of time you're walking through. So there's no such requirements. It's just a sightseeing experience. So teleportation is still valid. Yeah. So Ryan, correct. So that's why so Ryan is saying that people on wheelchairs use joysticks, correct, to move their PMD. But the main thing is that when they move the joystick, the actual wheelchair also moves according to how they move the joystick. So unless you create a simulated wheelchair that will turn when you turn the joystick, you can't really avoid the disparity in reality and virtuality. Yep. Just to answer your other question on what will be tested for the first quiz is everything up to today. All right. Everything up to this week will be tested next week. Okay. Last question. VR escape room experience. Sorry for spelling errors. Able-bodied users, and I mentioned that naturally this is escape room, right? So the escape room all meant to be super immersive. The real thing, yeah. So VR should be also aimed with the same goals, right? Aim at the same goals. Oh, sorry. Never change screen. Okay. Thanks, Clarence. Yeah. What locomotion technique is best suited for this use case? Yay. Okay. Always good to see the highest bar being the correct answer. So few considerations over here. Firstly, immersion. We want it to be as real as possible. So yeah, we want the real walking. In locomotion literature, this approach, this locomotion technique is called real walking. Exactly what it is. So it means tracking the real motion using a lighthouse setup or something similar. Or inside out tracking if it's robust enough to track real walking. Yeah, so we want that as far as possible, but we need to check a few other things. Like just now, when the space is too big, like the real aircraft one, maybe the space is a bit big lah. but you need to know that the device actually supports that. But here we are talking about escape room. So most of the levels or in the scenarios in there is in a room. So therefore, a room scale kind of a thing is also pretty common. You know, a lighthouse setup can actually support quite big rooms just with two sensors, with two lighthouse sensors. So that's totally fine. So that's why the answer is absolutely the best answer lah, that we should use tracking the real movement, real walking movement in a physical space and translate that to the virtual space. Okay, but if things get a bit bigger, then we need to consider the options here, like our LTA project again. It's almost infinite walking. Yeah, you can walk round and round the HDB block, so it's impossible to do real movement in physical space, tracking exact real movement. But there are other methods as mentioned in the video content for this week as well, the YouTube video, like redirected walking. Okay, all possible ways to. I've not searched over here, yeah, but you can find those methods over here. All right, redirected walking means you keep walking. When you turn right, it actually augments that turning and make it a bigger turn. Or when you walk, it's actually turning. When you walk straight, or when you walk curved, you're actually walking straight in the virtual world. So that's called redirected walking, so that you can accomplish much bigger spaces in a smaller space, accomplish much bigger virtual spaces, cover much bigger virtual spaces in a limited physical space. Okay, by redirecting the virtual space walking, when in actual fact in physical space you are walking in a different manner. Okay, so those are all methods, but that's quite a early work that is not implemented that well for real purposes. Okay, we come to the end. Let's see who is the top. Mings, thanks for not letting VR hater be the first in this class. Otherwise it would be embarrassing for me. All right. Yeah. All right. So Mings is the top scorer. Congrats, and send me your screenshot. And that's all. I'll see you guys on Slack this Thursday. And also remind you a few more times, okay, next week, what's happening for the quiz. Okay, so that you all would get on your toes. Okay. And please start implementing as well. Okay. The quiz would be, as you know, related to implementation. Okay. All right. That's all. Bye. Yes. Thanks, everyone.